Next example, a firm makes two types of furniture, chairs and tables. Profits are 20 rupees per chair and 30 rupees per table. Both products are processed on three machines, M1, M2 and M3. The time required for each product in hours and total time available in hours is given in the following table. These are the three machines, M1, M2, M3. Both of these products, chairs and tables, are processed on these three machines. Each chair requires 3 hours on machine M1, 5 hours on machine M2, 2 hours on machine M3. Whereas each table requires 3 hours on machine M1, 2 hours on machine M2, 6 hours on machine M3. And how much time is available on each machine is given. 36 hours are available on machine M1, 50 hours are available on machine M2, 20 hours are available on machine M3. Formulate the above problem as a linear programming problem. We first try to represent all this data in a tabular form. A firm is making two types of furniture, chairs and tables. It is given that profits are 20 rupees per chair and 30 rupees per table. And both products are processed on three machines, M1, M2, M3. Time required for each product in hours and total time available in hours is given in the following table. So both of these products are processed on machine M1, M2, M3. Now each chair require 3 hours on machine M1, 5 hours on machine M2, 2 hours on machine M3. Each chair require 3 hours on machine M1, 5 hours on machine M2, 2 hours on machine M3. Each table require 3 hours on machine M1, 2 hours on machine M2, 6 hours on machine M3. 3 hours on machine M1, 2 hours on machine M2, 6 hours on machine M3. And how much time is available on these three machines? is given. On machine M1, 36 hours are available. On machine M2, 50 hours are available. On machine M3, 20 hours are available. So this is how we can represent the data in a tabular form. So let us represent all the data in the given LPP in this tabular format. A firm makes two types of furniture, chairs and table. So there are two products, chair and table. Profits are 20 rupees per chair and 30 rupees per table. This is a column for profit, and the profits are 20 rupees per chair and 30 rupees per table. Both products are processed on three machines, M1, M2, M3. The time required for each product in hours and total time available in hours is given in the following table. Both of these products, chairs and table, are processed on three machines. Each chair requires 3 hours on M1, 5 hours on M2, 2 hours on M3. Each chair requires 3 hours on machine M1, 5 hours on machine M2, 2 hours on machine M3. Whereas each table requires 3 hours on machine M1, 2 hours on machine M2, 6 hours on machine M3. Each table requires 3 hours on machine M1, 2 hours on machine M2, 6 hours on machine M3. Total available time on the three machines is given. 36 hours are available on machine M1, 50 hours are available on machine M2, 20 hours are available on machine M3. Time available in hours. On machine M1, 36 hours are available. On machine M2, 50 hours are available. On machine M3, 20 hours are available. So this is the data given in the problem. Let us formulate this data as a linear programming problem. Suppose that a firm makes x1 units of chair and x2 units of table. Now the objective of the firm is to maximize the profit of the firm. Let us find total profits of the firm when it makes x1 units of chair and x2 units of table. Total profit of the firm is equal to profit on x1 units of chair plus profit on x2 units of tables. Let us denote this profit by Z. Now look at the table. Profit per unit is given. Profit on 1 unit of chair is 20. A firm is making x1 chair. So total profit will be 20 into x1. Plus profit on 1 unit of table is 30 rupees and a firm is making x2 units of table. So total profit will be 30 into x. This is called the objective function. Suppose this is equation number 1. Now let us determine the constraints in the problem. There will be 3 constraints. One of the constraint will be on machine M1, second will be on machine M2, third will be on machine M3. Now let us find total time required on machine M1 if a firm makes x1 units of chair and x2 units of table. How much total time required? Now the total time required in making x1 units of chairs and x2 units of tables on machine M1. It is equal to. Now look at the table. Second column is requirement of time per unit of chair and per unit of table on machine M1, M2 and M3. We are calculating the time on the machine M1. Each chair requires 3 hours on machine M1. So x1 unit will require 3 into x1 hours. plus each table requires 3 hours on machine M1. So X2 units of table will require 3 into X2 hours on machine M1. So the total time required in making X1 units of chair and X2 units of table on machine M1 is 3x1 plus 3x2. Now note that on machine M1 36 hours are available, and this is the total time required in making X1 units of chairs and X2 units of tables on machine M1. So this time on machine M1 we are using to manufacture X1 units of chair and X2 units of tables should not be greater than 36 hours. This total, that is total time required on machine M1, should not be greater than 36 hours. That is 3x1 plus 3x2, which is total time in hours we are using on machine M1. This time should not be greater than 36 hours, and therefore the constraint on machine M1 is 3x1 plus 3x2 is less than or equal to 36. Suppose this is equation number 2. Similarly, we find constraint on machine M2 and M3. Next, total time required in making X1 units of chairs and X2 units of tables. On machine M2. It is equal to on machine M2 each chair require 5 hours. So X1 chair will require 5 into X1 hours. Each chair require 5 hours on machine M2. So X1 units will require 5 into X1 hours. Each table requires 2 hours on machine M2. So X2 tables will require 2 into X2 hours. So it is equal to 5x1 plus 2x2. Total time required on machine M2 is 5x1 plus 2x2. Note that only 50 hours are available on machine M2. So the total time required on machine M2 should not be greater than 50 hours. This is the total time required on machine M2. This should not be greater than 50 hours. This total time on machine M2 should not be greater than 50 hours. That is 5x1 plus 2x2. This time should not be more than 50 hours. So the constraint is total time required on machine M2 is less than or equal to 50. This is the constraint on machine M2. Suppose this is equation number 3. Next we determine the constraint on machine M3. So total time required in making x1 units of chairs and x2 units of tables on machine M3. It is equal to now look at the column for machine M3. Each chair require 2 hours on machine M3. So x1 units of chair will require 2 into x1 hours on machine M3. One unit of chair require 2 hours on machine M3. So x1 units will require 2 into x1 hours. One unit of table requires 6 hours on machine M3. So x2 units of tables will require 6 into x2 hours on machine M3. One unit of table requires 6 hours on machine M3. So x2 units of tables will require 6 into x2 hours on machine M3. So total time required on machine M3 is 2x1 plus 6x2. Now total time available on machine M3 is 20 hours. So this total time on machine M3 should not be greater than 20 hours. This total time on machine M3 should not be greater than 20 hours. That is 2x1 plus 6x2, which is the time required on machine M3, should not be greater than 20 hours. Hence, the constraint is 2x1 plus 6x2 less than or equal to 20. This is the constraint on machine M3. Suppose this is equation number 4. Also, non-negativity constraints are there. X1 and X2 are greater than or equal to 0. X1 equal to 0 means X1 represent number of units of the chair. If X1 is 0 means a firm will not make a chair. And X1 greater than 0 means a firm will make that quantity of chair. Thus, we have to maximize the profit of the firm using the available time on machines M1, M2, M3. Hence, the LPP is maximize the total profit Z This is the total profit 20x1 plus 30x2. We are denoting this profit by Z. So maximize 20x1 plus 30x2 subject to following constraints. Constraint on machine M1 is 3x1 plus 3x2 less than or equal to 36. Constraint on machine M2 is 5x1 plus 2x2 less than or equal to 50. And constraint on machine M3 is 2x1 plus 6x2 less than or equal to 20. Also, non-negativity constraints are there. X1, x2, both of these quantities, both of these variables are non-negative variables. So this is the objective function. These three are the structural constraints. And these are the non-negativity constraints. So this is the required LPP.